Welcome back to the Laura and Melissa show again.
Yeah.
Welcome back.
Welcome back. Thank you.
So, Laura, we are gonna start talking about the 90-degree launch. So, let's just see. What did you learn in this section?
Well, after building the 4 identical rockets, shooting them at 90 degrees was pertinent in using concepts such as outside vectors, parabolic paths, linear momentum, acceleration, GPE, KE, range, and other important formulas or concepts. While demonstrating these, we were able to not only solve them mathematically, but apply them to the 4D world we are living in. By doing the 90-degree shoots, concepts learned in class, as well as with further knowledge about launching rockets, we were able to demonstrate our understanding of into tangible performances. Also, by doing the 90-degree shoots, we used the range formula to calculate hypothesis for the landing distances of the 45-degree shoot. We learned how to shoot the rockets properly and the precautions to look out for while, during, and after the shootings. For example, we had to be careful of not losing a lot of water while setting up the rockets. Also, we became aware of other people surrounding the areas of shooting. If certain precautions were not taken, the lab data could have been extremely skewed, or people could have been hurt. As we have already learned in past labs, one miscalculation or screw-up can seriously affect the rest of the performance. The 90-degree launches were important for understanding concepts already listed, but also for future life. Any moving object will have GPE and KE, such as pendulums. Also, not only do objects have center of mass and gravity, but people do too. Modeling the ideas of these can be as simple as boys versus girls being able to lift a stool to their chest, or be as complex as astronauts and aircrafts go.
It seems kind of complex, but I'm sure you used a lot of formulas for this part of the lab. Can you list some of them?
Sure. Our understanding of problem solving, not only for this lab but for future labs, was enforced and clarified through them. Algebraically, as well as with calculus, we were able to apply our math skills. Formulas used during the 90-degree launch include velocity 1 equals velocity 2, which equals gt. The altitude equals dy, which equals 0.5 gt squared. The delta h, which equals the altitude, is dy. The kinetic energy equals 0.5 mass times velocity squared. And the time on the shaft was the distance on the shaft divided by the velocity. The acceleration was the velocity 2 minus velocity 1 over the time on the shaft, and the impulse was the mass of the rocket times the velocity.
That sounds great, and looks like you put a lot of hard work into it. But how do you think you could make this lab better for next time?
Well, for future labs, it would be beneficial to make sure we are precise with all measurements and are extra careful of anything conflicting how our data results will come out. Next time, it would be beneficial for us to be a little bit more organized with gathering our information. If we manage our time correctly and do multiple measurements to ensure accuracy, results can be perfected.
Great. So how did this group work together, Laura?
Well, our group worked very well together. We were able to share responsibilities and come up with precise work, resulting in 2 great launches. Michaela and Melissa were the photographers during the 90-degree launch. They both were able to take videos as well as pictures from different angles. Christian and I were extremely helpful in setting up the rocket in preparation for the launch. Sarah, as well as the other members of the lab group, wrote down information needed, such as materials, observations, procedure, and data. While Melissa typed up the data for the 90-degree launch, Sarah typed up the materials list, Christian the procedure, and Laura the observations.
That's a lot of work, Laura, but it seems like you guys really understood it. So can you tell us, what are some of the likes and dislikes about this part of the lab specifically, and can you compare and contrast it to other labs that you've done in this class and other classes?
Well, we definitely enjoyed this lab. It was a pretty fun lab. Watching the rockets get shot and seeing our work in the air was kind of cool. But compared to other labs already performed in this class, this one was one of the most excellent. Although it took a great deal of time to produce, the greatest amount of knowledge, time, and effort was put into it, making it very worthwhile once success was achieved during the launching. This lab was awesome.
Do you think then, I mean, I think I have your answer, but do you think you should keep it for next year?
Well, I think it should certainly be kept for next year's class. Many kids find it exciting to perform such a lab. Also, knowledge learned in class is greatly demonstrated by doing this. During the 90-degree portion of the lab, information found here was also useful for the 45 launching. Because of this, it is informative as well as exciting to perform. The concepts learned in class are greatly clarified, being able to see them in real life, not just in a textbook.
Well, it seems like the 90-degree launch was very successful for you guys and
Yes.
that you learned a lot. So we're just going to take a quick break, Laura, and maybe touch up your makeup. And then we will come back and talk about the 45-degree launch. Stay tuned.